Hi students, and myself Kumaravel, Assistant Professor, Department of Marine Engineering, Amet University. Today I am going to present the topic gear pumps. Actually gear pump is before go for a gear pump, we have to know what is pump actually. Pump is nothing but it's a device which convert a mechanical energy into hydraulic energy to transmit a fluid from one place to other. For all these things and all, we are using pumps. In that many types of pumps are there. In that I am going to explain gear pump. Actually gear pump is a positive displacement pump. And what is that positive displacement pump is nothing but it will create a constant discharge. But in case of other pumps and all, it won't create a positive, that constant discharge. As it is creating a constant discharge, we are calling this one as a positive displacement pump. There are different types of positive displacement pumps are there, and this is one of the type. Gear pump is one of the type. And in that gear pump also, we have two types, external gear pump and internal gear pump. In external gear pump, we have, by using two gears, both have a same spur gear. With the help of that gears, we are transmitting the liquid. Okay. First we are going to see about how the external gear pump is working. Now I am going to explain external gear pump. Actually here this one is a cross section view of external gear pump, and here we have two gears. One is driving gear and the next one is driven gear. Driving gear is nothing but it will get the power from the motor and it rotate. Because of this driving gear, the driven gear also will rotate. This is a basic concept which is in a external gear pump. If you see the outer portion, that one is called as casing. This outer portion is called as casing, which will prevent the oil to escape. Okay. Here the general working of this external gear pump is, from the electric motor the driving gear will start to rotate, and while it rotates, what will happen means, if you see in between the two gears, between the driving gear and driven gear, we have a mesh and unmesh. It will occur. So while it occurs, what will happen means, the basic concept of the pump is two things. First is suction and the next one is delivery. For suction what we need is the lower pressure, vacuum pressure, and for delivery we need high pressure. This is a basic concept of pump. This is a concept which is used in all the pumps, not only in positive, in all the pumps we are using the same concept. Suction first part and the second part is a delivery. Here also the same thing will happen. First one is suction. How the suction will happen in the gear pump means, if the two gear, with the help of this one is here the motor shaft will be connected in the driving shaft. While the motor rotate, automatically the driving gear also will rotate. Okay. So while it rotate, it will make the rotation of driven gear also. So in between these two, the mesh and unmesh of the gear will occur. So because of that, what will happen means, you know what is vacuum, absence of air. So while it contact and if it release, what happen means, in between these two portion the vacuum will be created. So you know, if the vacuum created, automatically it will compensate that pressure. So because of that, it will suck the objects. So here this green indicates suction, oil, suction portion of the oil. From here the oil will enter because of the suction which is created in between the gears. Okay. So while the suction created, automatically the oil will suck into the gearbox. The second portion is, as I said before, it's a delivery stroke. For delivery stroke, what we need is high pressure. How that high pressure will create that means, while this will rotate with more than 1000 rpm, this gear pump will rotate 1000 or more than 1000 rpm. So if it rotate with that much high rpm, so it will create a high pressure in between the casing. In between the casing, the high pressure will be created. So because of it, while up the green indicates, I said it's a suction. So once it crosses this area, automatically this, if you see here, the space between the casing and gear is very less. It will in the micro level. So the oil won't escape from that gears. So it will just compress the oil towards outward, and this process will occur continuously to create to give a continuous discharge of oil. Okay. So actually the gear pump mainly we use to transmit the oil from one place to other. For that only we are using the gear pump. This is a general working. First one, we have to create a suction in between these two gears, and then while it rotates with high RPM, because of the high pressure, it will compress towards outward. And this is a basic working of the external gear pump. If you see here, this is a parts which is available in the external gear pump. Here the two gears, and this one is what? Driving shaft, which is connected to the electric motor, and with the help of it, the driver gear will rotate, and here this one is idle gear or driven gear. In this portion only we are getting the suction, and then after it will move towards outward with the help of the pressure. And if you see the advantage of these pumps and all, the first main advantage is high speed. It will rotate with high RPM, so it can easily transmit the oil, and then high pressure. As it create a high pressure, it can easily transmit a high viscous liquid. High viscous liquid is nothing but oils, oil and all high viscous. So it can also use it to transmit the oil. And then the main thing is quiet operation. If you see if you stand near to that gear pumps and all, you can't even able to listen to the noise of the pump, because in that way it is very quiet operation which is happened in a gear pump. A disadvantage in sense, even though if it is transmitting the oils, it can't able to transmit the solid items and all. So we can't able to transmit the solid materials in a gear pump. That is the main disadvantage. And where we are using this kind of gear pump in sense, mainly to transmit the fuels, oils, and then the blendings, and then acids. To transmit the acids and all, we are using this kind of external gear pumps. So this is about the external gear pump. Generally we have two types of pumps, external gear pump and internal gear pump. At first we are seeing the external gear pump. Now what we are going to see is an internal gear pump. This is also same like an external gear pump, but the design and working will be somewhat different. That we are going to see now. And the next thing what we are going to see is an internal gear pump. Internal gear pump is same like your external gear pump, but the thing is here the design is somewhat vary. Here in external gear pump we have two same gears, it will rotate and will create a vacuum. But in case of internal gear pump, what we are going to do is here the inner gear and then outer gear. Two gears are there. So if the inner gear rotate, here the driver gear is an inner gear, and then the driven gear is an outer gear. So with the help of the electric motor shaft is connected to the inner gear. While it rotate, what happen means, because of it the outer external gear also will rotate. So in a external gear, in between the two gears, while it contact, it will create a vacuum. In the same way here also, in between these two gears there is a contact portion is there. While it mesh and unmesh, so what will happen means, in between these two portions we have a vacuum. The vacuum will be created. So that is the first part. Suction is the first part. So for a suction we need to create a vacuum. Okay, for that will be happen while the gear will mesh and unmesh in between these two portions. So if it rotate continuously, what will happen means that suction will be created. So this same like that external gear pump, here also that green color indicates the suction. So that suction portion of the oil. So that oil will enter into this internal gear pump because of the mesh and unmesh in between these two gears. Okay. So while it rotate continuously, high vacuum will be created and that oil will be enter into this portion. And then after this, here one more portion, extra part is there. That one is crescent. What is the need of this crescent means? What is the need of this crescent means? It will separate the suction and compression. Suction and compression, in order to separate it, we are using that crescent. So here, in between this crescent only, the suction and compression will occur. That if you see here, the one part of the crescent will give suction, the second part will give the delivery stroke. Okay, so it will separate the suction and compression in the internal gear pump. So while it rotates here, the green color indicates suction, I said. So because of this mesh and unmesh, the suction created and the oil will enter into this gear, and then after, because of that rotation, high speed, it will compress the oil and it move towards outward. Okay, this is the process which is occur in the internal gear pump. It's same like external gear pump, but as I said before, that design will be differ. This is the actual part which is used in a internal gear pump. If you see here, this is an internal gear and this one is an outer gear. It's a cross-section view. In order to know the working, it is given as a cross-section view. And from here, the electric motor will give a power to the internal gear, and if it rotate in between, in this portion, the suction will occur and the oil will enter into this portion, and then it will move towards outward. That is nothing but the delivery process which is occur. The main advantage of this internal gear pump is high viscosity. We can able to transmit high viscosity liquids and then non-pulsating discharge. Okay, we can able to transmit non-pulsating discharge also possible in internal gear pumps. Okay, these are all the advantages. And then if you see the disadvantage, in case of disadvantage means it's very limited disadvantages. First one is very pressure limitations, medium pressure. We can able to utilize for medium pressure alone. And then overhanging will be occur often in an internal gear pump as compared with the external gear pump. These are all the some of the disadvantages. And then if you see the applications, it is used to transmit alcohol. And then the main application is it is used to transmit the solvents and then resin, polymers. In order to transmit these things and all, we are using only the internal gear pump. Okay, this is about the working of internal gear pumps. Okay, so far we have seen two things, as external gear pump as well as internal gear pump. And now what we are going to see is, we are going to see about the related pumps which is related to gear pumps. Clear? The next thing what we are going to see is screw pump. Screw pump is same like same like a gear pump. It will create a suction, compression, all the things, and it will be used to transmit the oils. But not only for oils, it also used to transmit the solid materials also. Here, if you see here, the main working is just the screw is here. Okay, this is nothing but a screw. While it rotates, what will happen? It's same like, I think you all seen the screw conveyor. Screw conveyor, you all know, isn't it? It is used to transmit the coals and all. In a coal mining place and all, you can able to see that screw conveyor. While the screw rotate, what will happen means that coal will move from one place to other. That is the major working of the screw conveyor. Here also we are using the same thing, but in case of liquid, if you want to transmit, then we used to call this one as a screw pump. The working is same, but in order to transmit the liquid, we are calling this one as a screw pump. Here we have main parts of this one is screw. This one is a screw. So from here the oil will enter. Here the feed port. Feed port is nothing but from here we are going to give an inlet to the screw pump. While the screw rotates gradually, it will gradually move that oil and it make the discharge here. Okay, where we are using these things is and all, screw pump and all, some semi-solid items. Okay, if you want to transmit the semi-solid items and all, we are going for screw pump mainly. This is a actual diagram of actual component of screw pump. If you see here, this one is a screw and it is connected to the electric motor. While the electric motor rotate, what happen means the screw will also rotate. The screw, once the screw rotate, what will happen means here the inlet will be there and it gradually rotate the component and it push the component towards outward. In order to transmit one place to other, we are using this. The next thing what we are going to see is a vane pump. It is somewhat complex to understand the working. I think you all know the working of reciprocating pump, isn't it? Reciprocating pump means what? It's like while the piston moves outward, the suction will be created, and once the piston moves downward towards the cylinder, it will compress the liquid and push the oil towards outward. This is the working of reciprocating pump. Here also we are using the same concept. In a vane pump also we are using the same concept, but here the small vanes will be there, and that vanes will act as a pump, a small pump. Here if you see, these are all the vanes. Vanes are nothing but, here we all know the eccentricity. We know what is eccentricity. By using the concept of eccentricity, we are going to operate this vane pump. Here this center portion is called as rotor, and this center portion is called as rotor, and this one is, the outer one is called as casing. Okay. If you see the rotor to casing, it is not fixed at the rotor is not fixed at the center part, isn't it? So because of that, what will happen, if it rotate, the to and fro motion will be occur. By utilizing that mechanism, we are doing the operation of vane pump. Okay. Here if you see, here this is an inlet. This is an inlet. While the oil enter into this inlet, what will happen means, here the vanes, here the vanes are there. No, the vanes are nothing but a small cavity portion. Okay, the cavity portion. So what will happen means, it will create a to and fro motion. Okay, it will create a to and fro motion. If you see this diagram, you can able to understand this diagram. By using this diagram, you can able to easily understand the working of vane pump. Okay, this blue color indicates water. Okay, here while the water enters here, these small portions are called as vanes. So as I said before, this rotor and outer casing is not in a center, not exactly in a center. So what will happen means, while the rotor rotates with the help of electric motor, it will create eccentricity to the outer casing. So because of that, the vane will rotate in a to and fro motion. So if you see here, let us consider any one vane. Okay, it will be easy for you to understand. If you consider one vane, this portion, so what will happen means, if it rotate here, the vane will move towards upward and downward inside the rotor. Okay, so what will happen automatically, if it move towards outward, the cavity will be created. Sorry, the vacuum will be created. So because of that vacuum, the oil will suck into the vanes, and then again if it move to the next 90 degree, what will happen means, again the vane will move towards the rotor. So because of that, the compression will occur. So what will happen means, the oil will move away from the vane. So this will occur continuously, and it will give a continuous process. Okay, so this is the working of vane pump. Okay, next thing what we are going to see is lobe pump. It's same like your external gear pump. In external gear pump, what we are using? We are using the two external gears. The external gears will rotate, and in between the gears we have a vacuum, and because of that vacuum, what will happen? The oil will suck into the oil will suck into the port, and then while it rotates with the high RPM, high pressure will be created, and because of that pressure, it will suck towards, it will just push towards outward. That is the thing happening here. But the main disadvantage of this gear pump is, the teeth are very minute. Okay, the teeth are very minute, so it will transmit only the oil items, liquids. Okay, it can't able to transmit the semi liquids. Okay, semi solid or heavy liquids, we can't able to transmit. So for that reason only, we are using this lobe pump. Okay, if you see here, as compared with gears, here the lobes, this portion is called as lobes. Lobes are nothing but the large portion. If you see here, in between the two lobes, we have many portion, space will be more. But in case of gear pump, in between the two gears, the space is very less. So we can't able to transmit any heavy liquids or semi-solid particles. We can able to transmit only oil. So that is the main disadvantage of external gear pump. To avoid that thing, we are using lobe pump. If you see the working of lobe pump, here in between, but the working is same, but only the, instead of gears, we are transmitting, we are replace the lobes. That's the only difference between the external gear pump and lobe pump. Okay, here if you see that lobe pump, the same working, while it rotate, what will happen? In between these two lobes also, the vacuum will be created. If it rotate with high RPM, in between these two lobes, the vacuum will be created. Okay, once the vacuum created, automatically what happen? The oil will suck into the port. Okay, so and it rotate with the high RPM, it will push the oil towards outward. Okay, this is a working of low pump. Okay, the next one. The next thing what you are going to see is single acting reciprocating pump. As I said before, not only the gear pump is a positive displacement pump, the reciprocating pump also a positive displacement pump, isn't it? The positive displacement pump is nothing but it will create a constant discharge. Only for that it is called as positive displacement pump. Okay, now we will see the working of single acting reciprocating pump. Here the main parts of the single acting reciprocating pumps are piston, cylinder, crankshaft and then connecting rod. Here these are all the main parts. So what will happen means, while this crankshaft is connected, the crankshaft is connected to the electric motor. While the electric motor rotates, automatically the crankshaft will rotate. Okay, so that power will transmitted to crankshaft. Once the crankshaft rotate, that rotary motion will be converted into reciprocating motion. Clear? So once the crankshaft rotate, it will the power will be transmitted to the through connecting rod to the piston. So from here, from A, while the crankshaft move from crankpin move from A to C, the piston will move from that corner to the left corner to the right corner. Automatically what will happen, in this portion the vacuum will be created. Inside the cylinder the vacuum will be created. Once the vacuum created, automatically the oil will suck towards upward. Because of that vacuum, the oil will suck towards upward and it will be stored inside the cylinder, and again if the crankpin move from C to A, what will happen means the piston move from left to right. That means it will create a compression to the cylinder. So because of it, what happened, the oil or water which is available inside the cylinder, it will push towards upward, and that is nothing but a delivery stroke. Okay, this pipeline is called as suction pipe and this one is called as a delivery pipe. Okay, so you can ask one question. Once the suction created, we can't able to still make the water still in the cylinder, isn't it? So for that only we are having the valves, suction valve and delivery valves. What is the working of this suction and delivery valve means, it will retain the oil in the cylinder itself. Okay, during suction it will retain the oil in the cylinder itself. So then only until the delivery process start, the oil will be there inside the cylinder. If the suction valve or the delivery valve is not there, so what will happen? Automatically once the suction created, suddenly the oil will come down again. Okay, so in order to retain that oil inside the cylinder, we are using these valves. That is working. Okay, so here after that we used to call this one as HT is nothing but delivery head and HS is nothing but the suction head. Where we are using this kind of single reciprocating pump means where we need high suction for high height, but we can't able to transmit high quantity of liquid, but for more head, in order to transmit the liquid, we are going for this single acting reciprocating pump. Okay, the next thing what you are going to see is double acting reciprocating pump. Okay, it's same like a single acting reciprocating pump, but the difference is in a single acting reciprocating pump we are utilizing the one portion of the pump, but in case of double acting reciprocating pump we are utilizing both the portion. That means both the portion of the piston we are utilizing. If you see the diagram, in the single acting reciprocating pump we are use only the left portion of the cylinder. Okay, here during suction the oil will suck towards the cylinder and during compression the oil will move towards upward. That process will occur in a single acting reciprocating pump. If you see here, while the piston move from right to left, what will happen? The compression will occur in this on the left side. At the same time, the suction will be created on the right side. But we are not utilizing in the single acting. So for that reason, not utilizing on the power of on both the side, we are going for double acting reciprocating pump. Here we are using both the side of the piston. Once the piston move from right to left, what will happen means here the compression will occur and in this portion the delivery stroke will occur. The suction will occur and here the delivery stroke will occur. At the same time, if the piston move from left to right, what will happen means here the suction will be created, and in this portion the delivery will be created. Okay. So for that only, in order to utilize that, we are going for double acting reciprocating pump. Double acting reciprocating pump, it will give the double the times of discharge as compared with single acting. In a single acting, we used to call ALN by 16. Discharge Q equal to ALN by 16 for single acting. But in double acting reciprocating pump, we used to call 2 into ALN by 60. That is nothing but it will give double the times of the discharge as compared with single acting. That's why it is called as double acting reciprocating pump. Okay. And here if you see the single acting reciprocating pump, the one more topic, important topics are there. That one is called as air vessel. Actually, what is meant by air vessel means, here as I said before, it will give a constant discharge. But even though there is a sinusoidal variation in the pump, in order to avoid that, we are using air vessel. Air vessel is nothing but a temporary reservoir. This one is called as a temporary reservoir. How it will work means, here we used to keep the air vessel on both the side of the cylinder, top and bottom portion of the cylinder. How it will work means, listen, once the piston move from left to right, what will happen? The suction will be created, I said before. While because of the suction, the oil or water will enter into the cylinder. But we can't say we can suck the oil or water in a same level. Okay, it won't occur. There will be a variation in the level. So in order to maintain the constant level, what we have to do is, we have fixed the air vessel on both the side of the cylinder. At the beginning, during suction also, we have a air vessel. What is the purpose of this one is, let us consider we need 1 liter continuous discharge, but while it suck, what will happen means, it will suck 1.5 liter approximately. So in that case, what happen means, that 1 liter will move to the cylinder, the remaining 0.5 liter will move to the air vessel. And as I said before, air vessel is a temporary reservoir. So in that case, here it will be available 1 liter of oil, and that during compression, and that oil or water will move to the tank. And here also, in the other places, on the compression places also, we have what? One air vessel. What is the need of that air vessel means, here also, once let us, in the same way, let us consider the discharge also. We need a 1 liter of discharge, but while it compress, it will move 1.5 liter. Okay, in that case also, from here, from the cylinder to the discharge pipe, while it go, that 0.5 liter will move to the air vessel, and the remaining will move to the tank. Okay, this will occur in the air vessel, not only in the positive side but also on the other side. That means, if low quantity of oil or water will come, so let us consider, while it suck, it will give only 0.5 liter. In that case, what happened? Here remaining 0.5 liter will be there, right? So that will given to the cylinder. So totally here 1 liter will be available inside the cylinder. In the same way, in a discharge also, suppose if it compress the oil of 0.5 liter, what happened? In the air vessel also, we have 0.5 liter of water. So this will combine together, and we will get 1 liter of water. For an example, I am saying, okay, the discharge will be 1 liter per minute. Like that, it will discharge. Okay, for that purpose only we are using air vessel. If you not use the air vessel, what will happen means, it will create a sinusoidal vibrations. Okay, the main problem what will occur in the air vessel means cavitation. What is meant by cavitation means the formation of bubbles. Okay, that is a negative thing in a pipe. Once the bubbles form, what happens means, during lower pressure the bubble will form, and it move towards higher pressure. So what will happen means that the bubble will burst, and it will leads to the cavity. Okay, to avoid that cavities and all, we are using this kind of air vessels. Okay, once that process is called as cavitation. We used to call that one as cavitation. Clear? And this one is a air vessel. I said already, air vessel is a temporary reservoir. You can now you can see how the air vessel will work. This is a cross-sectional view of air vessel, 2D diagram of air vessel. So here what will happen means, inside the air vessel we have a compressed balloon or a diaphragm. It will be available inside the air vessel. So what will happen means, let us consider, as I said, the same example. We need 1 liter of oil. 1 liter of oil or water, it has to transmit through the pipeline. Suppose here it will be designed in such a way. Suppose if it come more pressure, more oil around in the range of 1.5 liters, what happen means that will give high pressure, right? That high, because of the high pressure, it will compress the diaphragm. It is compressible. Air diaphragm, it is compressible. So it will compress. Automatically what happen? There will be change in the volume. Okay. Once the diaphragm compress, the volume of the diaphragm will reduce. In that volume, the oil will be stored inside the air vessel. Okay. And here the remaining 0.5 will be stored in the air vessel. The constant 1 liter will be moved towards outward. Okay. So that is a process which is occur. In another way, that is, if lesser quantity of oil or water, if it pass, for example, if 0.5 liter will move towards here, it will be in the range of 1.5. So what will happen means the diaphragm will start to expand. It will start to expand. Because of that expansion, the oil or water which is available inside the diaphragm or air vessel, it will push towards outward, because it will become lower pressure, right? So what will happen means that oil will move towards outward. So because of it, that excess oil which is available in the air vessel, that will push towards outward. So as compared with inlet, the outlet will have excess oil. So that is the process which is occur in the air vessel. Okay. And what are the material we are using is, the outer casing is cast iron, but the inner material is a skinning material, that is diaphragm. Diaphragm is nothing but the compressible one. Clear? So only because of it we are getting the constant discharge of oil. Okay. Okay, in that diagram, in that video we have seen the gear pumps working, and apart from that gear pump, we also seen the other types of pumps also, like a low pump, screw pump, and positive displacement. All the types of positive displacement pump we have discussed, and in the next video I will explain the remaining pumps. Thank you.